Our planet generates an incredible amount of extraordinary phenomena. Some we take for granted, even if they are a little difficult to predict. Others occur to us as nothing short of miraculous. Often, these are events in places seldom seen by people. They are rare, mysterious, and many seem outright impossible. This series encapsulates the remarkable with the exceptional. Is seeing really believing? With the help of leading scientists, fact will be separated from fiction. Join us as we delve into the magical sea sparkle found in the waters of Tasmania and beyond. Take a trek through the ancient gorges of Karijini in the outback of Western Australia and probe into the Mars-like landscape of Kverif in northern Iceland. It is a journey taken with eyes wide open. Welcome to Impossible Planet. It's like something from a science fiction movie. An incandescent blue shoreline, glittering with tiny specks of light. It's the ocean's answer to the starry skies above. A spectacle as rare as it is beautiful. But what could possibly make the ocean seem to produce its own light? The bays of Tasmania have been a favorite destination for those hoping to glimpse the aurora australis, or southern lights. But on rare occasions, the clear waters host a rival light show. Flecks of aquatic bioluminescence shimmer in the shallows, each wave crashing in a burst of brilliant blue. It's no wonder this phenomenon is popularly known as sea sparkle.
They glow and they sparkle right in front of your eyes. Under certain conditions, it looks like a really dense, starry sky.
Sea sparkle has inspired wonder in everyone from casual beachgoers and photographers to marine scientists like Laura Smith.
When I was about 19 years old, I did a night dive, and that was the first time I'd really come into contact with very bright bioluminescence. It was the kind that you couldn't see from just looking at the water, but when you waved your hands around in front of you with your mask on underwater, it just lit up and left trails off of your hands. It was just the most magical thing.
Recently, Tasmania has become one of the few locations in the world most frequented by displays of sea sparkle. It has become a hotspot for marine researchers to study, including Professor Gustav Hallegraeff of the University of Tasmania's Institute for Marine and Antarctic Studies.
So all my life, I've been intrigued by microscopic organisms. I study these organisms. You can give me any water sample from anywhere in Australia. Any blind sample, I can tell you which area of Australia it comes from. And when I came to Australia, there was nobody looking in the water at microscopic organisms. One of the delights of working here on the waterfront is I turn up at work, scoop some plankton from the wharf, and see if there's something new.
This plankton, visible only at a microscopic level, represents a significant part of Earth's history, its origin no less.
This is how life started on this planet. It started in the oceans. And these organisms, they're still here, and they've remained largely unchanged since they first turned up about 3.8 billion years ago. All of the other organisms on the land are newcomers.
Each tiny sparkle is a living organism, and science has a rather poetic name for them: Noctiluca scintillans.
Nocti means night, Luca means light, so night light, and scintillans because it's behaving like a sea sparkle. It is, in a strict sense, not an animal, and it's not a plant. It's something in between. It's a different creation. Scientists refer to it as a protist.
Ocean-dwelling protists are one of the many microscopic organisms that make up plankton. Marine scientists used to think these glowing plankton were a type of jellyfish.
That's how it's been described in the 18th century. We now know it is actually belongs to a group that's called the dinoflagellate.
Dinoflagellates are found mostly in marine environments. Although they are single-celled organisms, each one is a marvel of survival and efficiency.
This is a plankton organism, so they're mostly single-celled organisms, but these cells have everything in them to be successful. They have a nucleus, the tentacle that it can use to feed other organisms with and suck it into its body.
Unusual among dinoflagellates, the sea sparkle needs to consume other organisms to survive, and its ingenious hunting process may help create the concentrated blooms that light up our beaches. When Noctiluca scintillans runs out of food, it floats to the surface to hitch a ride on ocean currents.
The currents take it to new areas in hope that it can find new food there. And this very behavior allows it to accumulate onto beaches where you get those slicks, and that produce the bioluminescent spectacle.
By day, these blooms can sometimes seem as pink-colored slicks. But by night, these organisms produce that spectacular blue light display. It seems almost miraculous that a single-celled plankton can emit such brilliant light. So how exactly does an organism no bigger than 0.5 millimeter in size produce such impressive radiance? The secret lies in a chemical reaction shared by all bioluminescent life on our planet.
The phenomenon of bioluminescence is actually an enzyme reaction. There's an enzyme called luciferase that binds with a chemical called luciferin. When those two chemicals come together, it catalyzes a reaction and we have light.
Although we know the chemistry behind sea sparkle, its purpose is somehow still murky.
We don't even really know why it is that they produce bioluminescence, so there's still a major question around that.
Why has Noctiluca scintillans evolved the ability to glow? It's a mystery that has fascinated scientists for decades. The same chemistry is found in terrestrial organisms, including glowworms, fireflies, and fungi. Vertebrate and invertebrate, large or microscopic, these glowing critters all harness the same enzymatic reaction to produce their light.
It has different purposes for different organisms. Bioluminescent plankton most likely glows for the very purpose of deterring animals eating it.
The theory of sea sparkle as a defense mechanism stems from a key factor in the phenomenon's appearance: movement.
The swishing of the water is what stimulates them to glow. If you run your hand through a patch of water or you kick your boot into water and splash around, then you get waves of glowing light coming off of your hand or off of your boot, or a trail of light behind it.
Scientists posit that Noctiluca scintillans reacts to the percussion of waves on a shore, or the movement of a swimmer, in the same way it reacts to a predator, by lighting up.
With this particular species, if the water is calm, it doesn't do it. You need to have waves mechanically irritating the species. So we think it is to do with a predator, like a small fish, approaching this little plankton organism, wants to eat it, and then the organism produces a light flash. It's a bit like a burglar alarm, and then hopefully the fish scares off and runs away.
Ironically, these glowing lights seem to have the opposite effect on humans. But although many travelers visit places like Tasmania with hopes of witnessing this natural marvel, large-scale blooms are impossible to predict and uncommonly rare.
I've been in Tasmania 7 years now, and I've seen 2 that you don't need any disturbance of the water at all to be able to see them with the naked eye.
It takes a very particular set of conditions to produce these iconic glittering beaches. Our oceans are vast and deep, and sea sparkle often goes unnoticed, unless it's concentrated in a small area.
It's the physical contour of the beach that acts like a funnel. A lot of the blooms that develop along the east coast, they all end up sucked into that area.
Even if a bloom of Noctiluca scintillans drifts into the perfect location, visibility lies at the mercy of weather conditions.
To see them in such dense aggregations, you often need a gentle onshore breeze to hold them up in the heads of bays to concentrate them there. So it's often we see those blooms occurring after a large rainfall event, because that takes a lot of the nutrients off of the land in runoff and acts as a fertiliser, causing the algae to reproduce.
In addition to location, nutrients and favorable wind, temperature is also a critical factor.
Spring conditions are often perfect, where there's still a bit of rain around, the water's getting a bit warmer, and if you've got that breeze holding them onshore as well, things all come together for us to be able to see those beautiful displays.
For those lucky enough to be in the right place at the right time, the experience is otherworldly. Professor Hollegrave hopes researchers will discover more accurate ways of predicting sea sparkle blooms. But investigation into Noctiluca scintillans could illuminate not only our oceans, but also the possibility of life on other planets.
2 years ago, I was reading a paper in a very reputable scientific journal, where some scientists, using very clever radioisotopes, they decided to try and date the age of the water in our oceans. And the answer is that most of the water in our oceans is older than the age of our solar system.
The theory goes that all water shares a common source, created in the Big Bang. And if it shares a source, it might share other things, such as microorganisms, like the sea sparkle.
It really puts the whole idea that life on this planet, all these microscopic organisms in our ocean, that they actually have come from elsewhere. It's all coming from the same original water vapor and interstellar space.
By examining how Earth's simplest organisms survive in hostile environments akin to those on other planets, we may get a better idea of where and what to look for in the search for alien life.
And we're growing our terrestrial Earth organisms under those conditions, and they survive very well, because we know there's gonna be similar creatures out there somewhere.
A sight like sea sparkle can transport us to another world. And yet, it's also a testament to how much our planet can still astound and surprise us.
It is just spectacular to see something in nature that you can wonder about, and the fact that it brings the public back to nature, rather than sitting behind a television screen or a computer game. This is so much fun.
I find it fascinating because these tiny organisms can produce their own light, and to me that's something magical. It's science meets fantasy. It's just incredible.
Among the dry outback of Australia is a unique slice into our planet's past, where gorges hold incredible secrets about the events of this world, and where one of the oldest formations on Earth sustains life in the most unlikely places. This is the world of Karijini. Karijini means hill country in the local Banjima language. Situated in the central west of Australia, these rolling plains reach out to the horizon before suddenly opening up like a grinning mouth.
The visitors from overseas, even Australian people themselves, they feel that connection to the country, to the land is speaking to them.
For the people who come here, Karijini has plenty to tell them.
So we're standing here at the top of the centre of the Earth, 120 metres above the bottom of the gorge, with the oldest naturally exposed rock formation in the world. When you come down into the gorges, you feel like you could be in another world.
My first look at Karijini was back in the 90s, and the one thing that blew me away was on the top, the area is arid, like your spinifex, typical, borderline desert, a few sand dunes here and there. But then walking down into the gorges and into the depths, it's like you're in a tropical paradise from the Devonian.
Each perfect layer of rock that lines the walls possesses clues about the park's creation. A process that began 2.5 billion years ago, when Karijini was covered in ocean.
Ash fell down and also settled down into water column and onto the ocean floor. These are sort of got volcanic origin. So they're pieces of rock that exploded, bang, ash, fall, and then got consolidated. And these shale layers have got some volcanic material in them, which indicates that there must have been massive volcanic eruptions occurring at that time.
These underwater volcanic eruptions were the source of the metals we find captured in the layers of rock today. Layers that have taken millions of years to form.
They basically rained out of these ancient Archean waters and precipitated onto the floor. This takes millions and millions and millions of years to form.
Karijini's Kermit Pool houses some of the earliest layers of rock in the park.
So we're going back in time, I suppose. The rock is older, and this is where we really can see that banding. The rock's far more polished, less oxidisation, so you can really distinctly see the layers of light and dark.
It's these rocks that point to a time when the Earth survived with scarcely any oxygen.
Some of the first oxygen on Earth is responsible for creating that bluey layer of rock.
The colors of the walls indicate a time when carbon dioxide was succeeded by oxygen as the key to life on Earth. The presence of oxygen changed the color palette of the park from the metallic gray hues that would have once dominated.
So the orange, the classic Pindan red that we have out here, that comes from the iron oxide, or as we commonly know it, rust.
These layers are another hallmark of Karijini. Few places on the planet present such perfectly assembled layers of rock that appear to have been meticulously organized on top of each other.
The rocks are so beautifully flat that the oldest ones are on the bottom and the youngest ones are on top.
That these layers of rock should have remained so straight, so even for so long, is improbable. Our dynamic Earth, after all, is prone to getting a little creased now and then.
You've got a beautiful cross-section of the layers, quite flat layers, which is really, really amazing for rock, which is around 2.5 billion years old.
It's as though for all this time, this piece of the planet was allowed to rest here, undisturbed. No wonder the Banjima people, inhabitants of Karijini for over 20,000 years, should also regard this area as a reliable resting place.
Our people, when they travel through country and that, they stop in these places. There's water there, there's fish there, there's other food around the place. And so that's why then the gorge systems themselves, whether you're in them or outside, there's rock holes and springs. So when people used to walk through country, then they know which way they're going.
In a landscape that is usually hot and dry, the rock pools and streams are precious resources. Resources which the Banjima believe have been left there by their creator during a period known as the dream time.
They've been there and put there by what we refer to as the toro. It's a serpent, and they leave a mark as they travel through. These permanent springs, rock holes, and riverbeds, they leave them there for the public and for our own people. And as they travel through country, they got these special places in there that they know about. And so when they do travel, they know where they are, the names for them, and then that place will provide for them as well.
Places that provide are held with great esteem. Even the seemingly simple task of approaching fresh water is done so respectfully and with a greeting.
Water is very precious. Even us, the older ones, there's water there, we'll get a handful of water in our hand and then put it in our mouth and we blow that water back in the pool. And then we talk in language. And you're greeting the place, telling them who you are, you belong to country, and in return again, the country there will look after you.
Water is so highly prized that stories reinforce the level of respect people should be giving it.
At Circular Pool, Wallibindimuna, the Dreamtime story is that you can go and visit, all right, but only at a certain time of the day. And you got to make sure that your shadow don't fall in the water in there. Because if that happens, something might happen to you, or the spirits might then make you sick.
Banjima elder Maitland Parker grew up in Karijini, exploring its special places with his parents and grandparents. His connection to this country only grew during his 28 years working as park ranger there.
And us Aboriginal people, doesn't matter where we're from or where we are in this country, those permanent waterholes is that the warlu is still there. They're still looking after those places. That's why we then tell public not to create any disturbance and be silly, I guess, about these special areas where they are, so they don't stir them up and cause them to get angry. To us, it's real. It's our Dreamtime stories. It's in us here, and we believe that very, very strongly.
Evidence of powerful forces at play abound at Karijini. Arguably, the most defining force has been water. For hundreds of thousands of years, it has been carving out the magnificent gorge system that stands majestically now.
You know, water finds a crack and water will physically erode that area or physically weather that area, making it big.
Rainwater, which is naturally slightly acidic, began to gnaw away at the hard layers of rock that had been left intact for millions of years.
There's fracture planes, and these fracture planes are the point of weakness of which the water can travel along and start breaking down the rock and forming these gorges.
In some places, the irrepressible flow of water has created dramatic overhangs, as more resistant rock is able to withstand the flow that rubs past it.
So through here you can see we've got some overhangs and you can see an obvious layer that was geochemically weaker than the surrounding layers above and below. So erosion has had more of an impact on that layer.
As the water reaches a dead end, it turns back on itself in a circular motion known as an eddy.
You can see that we've followed a concertina fracture. That large crack up above us here has come down, and there's been another one running parallel to it, and that water has just found a way between the two, and this would have become a large eddy at one point.
In parts of the gorge, the water floods through a 30-meter wide corridor where it can reach heights exceeding a 2-story house. Its power is immense. Here in Hancock Gorge, the floods have left a signature of their strength.
So that's a large piece of Kangen, or cap rock. So that's been sitting right up on top of the gorge 200 million years ago, and then as the gorge has slowly eroded away, it's fallen down in a wet season and been washed down to this point. When you think of a rock that large being moved by water, it's pretty hard to get your head around.
It's this permanent water source that sustains the lush trees and ferns that huddle in the depths of the gorges. The soothing shade cast by the branches overlooking the flowing streams create a distinct, cooler climate down here. But this landscape wasn't always like this. Some scientists believe that the area surrounding the gorges was once damp and humid. The theory is based on 2 floral fingerprints known as remnant species. Their presence here today is a contradiction, because these are tropical plants, growing amongst an arid expanse.
So these 2 plants behind me are impossible plants. They have no right to be living out here in the Pilbara, yet here they are, down in the depths of Hancock Gorge, keeping their roots wet. Scientists use these to come up with the theory of how these gorges formed. They say that 200 million years ago, this whole landscape was very, very different.
The presence of these 2 tropical trees suggests the surrounding area was once covered in lush rainforest.
These plants being all the way down here shows us how the gorges were formed and the huge volumes of water that we've had through this part of Australia over the last 200 million years.
The trees, it seems, have followed the water as it has gathered deeper and deeper into the layers of rock.
In the grand scheme of things, you think that rock is the hard thing and water the fluid thing, but over time, water wins. And without the huge volumes of water, we wouldn't have such beautiful places as this.
Although appearing impossibly perfect in so many ways, it is a place that is still evolving.
As you walk down and then as you look up, you are looking through geological time, and all those different layers represent a different environment. So things change, and that's the dynamicism of the Earth. To understand that everything is connected.
Karijini connects us to our planet's past and seems to call on us to marvel at its present.
You will get a feeling of that sort, that you have a connection to that part of the country, and it will talk to you and it'll give you really, really good vibes about where you are and what the activities are happening around you.
I think there's a lot about this planet that we live on that we don't understand, and that we've got a lot still to learn. So I think some of the answers may be out here in Karijini.
You're literally playing with fire, aren't you?
If you look at the area, it's like the mountain is well done. It's been cooked.
It looks like a place not from this earth. A stark expanse of nothingness, except for the steam rising from holes in the ground. Hverith geothermal pools in northeastern Iceland. A desolate field of basalt lava rock, pierced by dozens of steaming pools filled with bubbling hot liquid. This area may look like a wasteland, but to the people of Iceland, Hverith is invaluable.
Hverir and the boiling mud pits of an area like that show us the pure strength of the warmth of the ground.
Iceland sits atop one of the greatest hotspots of volcanic activity on the planet. As a result, some of the most incredible natural phenomena have formed, like these geothermal pools.
Because you have all of this volcanic activity, volcanoes, magma close to the surface, the ground is hot. And as you go down, it gets hotter very, very quickly.
You have a short distance down to the magma, which warms up the bedrock. It cooks the steam in the bedrock, and the steam, heated and pressurized, finds a way to the surface. As the steam comes up, some of the minerals in the steam, as the steam evaporates, they're left on the ground. And the longer and longer it cooks, the thicker and thicker the layer of minerals gets. And what you end up with is a boiling mud pool.
Somewhere else in the world where you have a continent, the Earth heats up at about 25 degrees centigrade every kilometre. In Iceland, it's more like 100 degrees plus every kilometre. So it's about 4 times as hot as you go down. So what that means is near the surface of Iceland, in the Rift Valley in particular, you've got really hot rock, even magma really close to the surface. And so that produces what we call geothermal activity, geo meaning rock, thermal meaning heat, geothermal activity. And the surface expression of that will be steam.
The magma chamber that is heating Hverith is around 2 kilometers below the surface, with a temperature of over 1,000 degrees Celsius.
At the surface level, the steam and the mud can be 100 degrees centigrade, can be boiling. I mean, you wouldn't want to fall in or jump in.
One of the striking and most noticeable aspects of these boiling, bubbling pools is the amazing color.
Get these vivid sort of blues or orange or kind of browny colours. And that reflects how the pools form. So snow water, melt water, percolates downwards through cracks, gets heated up really quickly.
As the water travels under the ground, it reacts with the rock around it, absorbing some of the minerals.
If the rock is rich in iron, that iron gets translated into the fluid, and then when it gets back to the surface again, you get a coloration which is kind of red or brown or rusty colored. Blues are more likely associated with things like cobalt or chrome, other chemicals. So the composition of the colors of the lakes, of the pools, reflect the kind of history of the groundwater as it's percolated down, reacted with the rock, and then popped back up to the surface again.
Because of the extreme temperatures, the chemical reaction occurs at a far quicker rate than normal. Transparent water that permeates the rock takes between 2 months to 2 years to get its vibrant color before resurfacing. If the colors don't amaze you, the stench surely will. Upon arrival, the first thing to hit the senses is the unique and intense odor.
The smell that comes out is very distinct. Obviously, the first thing you notice when you get out of a car, you get this hit with this blast of kind of smell of rotten eggs.
As the groundwater percolates into the rock, it reacts with gases in the ground, such as hydrogen sulfide and sulfur dioxide. As the water comes back to the surface, it brings with it the odor of those gases. Kveirith is situated at the base of Krafla, a famous and powerful volcano that has been active since the last ice age, 10,000 years ago.
So one of the things about the Icelandic volcanoes is that they tend to be relatively flat. They're not steep-sided mountains because the lava that they erupt can flow away quite quickly, so you don't tend to build up a steep cone necessarily. So they're quite broad-based. So Krafla's about 25 kilometers from side to side.
Its highest peak is 818 meters tall and has a depth of 2 kilometers.
Volcanoes, of course, have been interesting for human beings. I mean, they're scary things, they're unpredictable. So ancient societies, you can understand they would have been in awe, as we are now. Krafla is interesting because the crater, the summit crater, is called Viti, which is the Icelandic word for hell. And so, you could understand, couldn't you, that if you got this Christian biblical description of hellfire and burning under the ground, then obviously the entrance in would be through a volcano.
Today, the crater is filled with sparkling water, a vibrant turquoise blue that regularly ices hell over. Just a short walk away, the same processes which create Kveirith are on vivid display through the extensive lava fields and unique structures that have formed.
Well, the area around Krafla in the northern volcanic zone is spectacular. It's cold, it's snow, crevasses, ice is rugged, the rock is dark, black-coloured rock everywhere. And then, of course, you hit this fantastic geothermal field close by, which is different altogether. It's hot, so you don't tend to get much snow or ice around it. Bubbling pools, different coloured water, steam, the smell of rotting eggs through the hydrogen sulfide, and the ground around it kind of stained red or rusty coloured, dark brown. A very contrasting environment, standing there and looking at the snow-capped peaks around you.
The incredible processes driving this unique landscape are invaluable to Iceland. The bubbling pools and steaming fields are an artifact of the incredible geothermal energy firing below, one that is harnessed and used to power the country.
Geothermal energy is the energy that we can produce out of hot ground. So in certain instances, there'll be, the rocks will be very dry but hot, and people will, what they do is they pump fluid inside and the fluids will heat up and they can extract the fluid. So what people do is you drill and they collect this hot water, which is used often for heating space, housing, and also for producing electrical energy.
There's two ways to generate geothermal energy. One is to pour your own water down. What happens in volcanic geothermal areas is that the water itself is part of the volcanic system. It's already there. So you're not pouring stuff down, you're just capturing what's there already. But you need to extract it, so you drill down the borehole. Probably the best place to find a really good source of supercritical fluid would be right close to magma under the ground, but not at the magma itself.
There are several geothermal power facilities in Iceland, which in total generate around 25% of the country's electricity.
I think the hottest geothermal well ever drilled was in the Krafla area, and they hit magma. It's about 400 to 500 degrees centigrade. What they did was very clever. They actually kept the well open, and you can extract heat in the form of not a gas or a liquid, but a supercritical fluid. Right, so what I mean by that is it's so hot down there that different kinds of water get drawn down into the rock, they heat up very quickly, and they turn into this supercritical fluid, which can then be extracted back up the pipe, the borehole, and used to drive turbines.
Supercritical fluid is a state of matter that isn't liquid or gas. It is beyond that, where the temperature and pressure are so extreme that it's classed as fluid and has very special properties.
Supercritical fluid carries about 10 times more energy than normal steam. So in fact, these geothermal areas are incredible natural resources for generating power and electricity.
It is a very renewable source of energy. If we can actually capture them at depth when they're really hot, then this is the energy we can produce.
It's a kind of win-win situation for Iceland. They've got the natural scenery, they've got these fantastic volcanoes that are natural spectacles in themselves, they've got energy they can tap from the volcano, and they've also got a tourist resource in the energy centre itself.
Another use for Iceland's magma-heated ground is one that is more simple and tastier to digest. Baking. Hverabrot, or hot spring bread, is a traditional Icelandic bread that is baked by burying it in the hot ground. The dough, which contains sugar, flour, rye, yeast, salt, and milk, is placed in a large pot and completely sealed. A hole is dug in the ground that is deep and wide enough to fit the entire pot. The groundwater here is boiling hot, at least 100 degrees Celsius at all times. The pot is placed over the bubbles, and the hole is filled in and marked with a rock. It takes 24 hours for the bread to bake. Because the ground temperature fluctuates, no two loaves of bread ever look the same. The result is a moist, slightly nutty flavored, delicious bread, served with butter on top. Iceland's unique landscape looks like that of another planet. In fact, according to scientists at the National Aeronautics and Space Administration, or NASA, it is very similar to the terrain of Mars. With the U.S. targeting Mars in their space exploration plans over the next few decades, NASA is utilizing Iceland for their research.
And how you train astronauts to explore and live in these environments is an interesting question. What NASA do is that we find areas in the world which are a bit like these volcanic places in Iceland we're talking about, which could be proxies for what a Martian landscape could be like.
Scientists have been studying the possibility of life on Mars and other planets for decades. Some planets are so hot that it seems impossible that anything could survive in such extreme heat. However, the geothermal pools of Iceland have inhabitants of their own.
Remarkably, you can get very tolerant bacteria that can live in these hot pools. The name for them are thermophiles. Thermophile, I mean, they love heat. And what makes that interesting in particular is that these could be areas for sites of life on other planets. Some people even claim that perhaps these pools, these volcanic pools, is where life first started on Earth, in these murky, orangey brown pools. So we're kind of all evolved from areas like Krafla and the volcanic geothermal fields around it.
Iceland's landscape is so alive and so active that the environment is constantly changing. This mud pool is here today, but may be gone next week.
You're dealing with nature, and this is not a thing fixed in time, so the mud flows may stop, because they get choked up, and another one starts over here, and that's a brand new thing.
A country where snow-covered mountains tower over a land of steaming hot liquid and rock. The contradictions of Iceland's landscape continues to fascinate people every day.
I guess that Iceland could seem impossible to people because of the contrast. If you were suddenly dropped like magic into the Krafla area and you're looking at this simultaneously hot, bubbling, boiling water, smell, pools of different vivid colours, surrounded by freezing ice. That feels impossible. It's a contradiction. It's two things. It's either hot on Earth or it's cold. How can it be baking hot as boiling water, and then frozen water around you in the hills together at the same time? That feels impossible.